Alright, we're going to start talking about proofs today. We're going to start out with algebraic proofs. A proof is a series of logical statements, each statement helping to prove an idea being backed by a given, definition, property, theorem, or postulate. So, in other words, every step that we do in solving a problem or improving a point, we have to give evidence or support for each step. And theorems, postulates, definitions, properties, the information that was given to us, those are all the things that we know are true, and therefore we can use those as evidence or support for everything that we do. The given is the information that's given to help you prove a statement. So it's the things that we know at the beginning of the problem. If you're given the information as a conditional statement, the given would be the if part of this conditional, the hypothesis. What we're supposed to prove is what you were asked to show using the givens and reasons. This is what we're trying to prove. And if you have a conditional statement, that would be the then part of the conditional, the conclusion. Alright, here are some properties that we're going to use in our proofs. So, a little reminder about these. These are things you should have learned for the most part. The reflexive property means that everything is equal to itself. So A is equal to A, X is equal to X, 7 is equal to 7. Reflexive property, just think of reflection in a mirror. What you see in the mirror should be the exact same thing as what's standing in front of the mirror. So same thing on both sides of the equation. Everything is equal to itself. The symmetric property, if A is equal to B, then B is equal to A. You can switch which side of the equation the two things are, and it's still true. That is the symmetric property that allows us to do that. So if I know 7 equals X, I can flip that around and say X equals 7 based on the symmetric property. The distributive property, if all of B plus C is being multiplied by A, we have to distribute that multiplication. So we do A times B and A times C. So we got AB plus AC equals D. So that's distributing, the distributive property. Substitution property, if A is equal to B, then A may be replaced by B in any equation or expression. We substitute all the time when we're doing our algebra. If I know X is equal to 5, then anywhere I see X, I'll substitute 5 in place of it. I'll replace the X with a 5. Substitution property. Okay, transitive property. If A is equal to B and B is equal to C, then A is equal to C. Okay, basically A and C are both equal to the same number, therefore they're equal to each other. Okay, the addition property just tells you can add the same number to both sides of an equation. Okay, if you have an equation, you can do any operation you want to one side of the equation as long as you do the exact same operation to the other side. Well, when we're specifically talking about adding, that's using the addition property. If I have this equation, I can add X to A and add X to B, and I still have a good equation. That's the addition property. Now, make sure we understand just because you do some addition doesn't mean it's the addition property. The addition property is specifically talking about adding the same thing to both sides of an equation. Same thing for the subtraction property, just dealing with subtraction. You can subtract the same thing from both sides of an equation. Multiplication property, you can multiply both sides of an equation by the same number. So I'm multiplying in both sides of the equation by X in this case. And the division property, you can divide both sides of an equation by the same number. So all of these here are talking about doing the same operation on both sides of an equation, not just any time you happen to do that operation. Okay, so that's a little quick review of some of those properties that we're going to use as we're doing our proofs. Let's start our first proof. So this one is given to us as a conditional statement. It says if 7 is equal to A and 7 is equal to B, then A equals B. So remember, the if portion of the statement is what's given to us. So I'm going to fill in what's given. 7 is equal to A and 7 is equal to B. And what we're going to prove is that A equals B. So whenever you do a proof, you have two columns, the statements column and the reasons column. So this is where you're doing pretty much all the work you're used to doing. And over here, that's where we put the postulate, theorem, definition, property, or whatever that supports each step that we do. Because we're starting out basic today, we just followed all those properties. Those are mainly what we're going to use today for our reasons. Now, when you start a proof, you typically start with given information. If you're going to argue a point, you got to start with something you know. So, we start with some given information. I know that 7 is equal to A. And the reason I know 7 is equal to A is because it was given. This is not something that's true all the time, but it's true for this problem because they told me it's true. They told me 7 is equal to A. I know that 7 is equal to B because that was given. Now, I have enough information just off the given to go ahead and prove what I need to prove. The last step in your proof should always be what they've asked you to prove. So we're supposed to prove A equals B. That's going to be the last step of the proof. Now, how do I know A is equal to B? Well, A was equal to 7, and B was equal to 7, so they were both equal to the same number. Therefore, they're going to be equal to each other. If you remember, that is the transitive property. And you can just abbreviate property if you would like. All right, let's look at the next one. If x divided by 4 is equal to 12, then x is equal to 48. So the if portion is what we're given. We know that x divided by 4 equals 12. What we're supposed to prove is x is equal to 48. So we always start with the given. I know x divided by 4 is equal to 12 because it was given to us. Now, if I'm just solving this equation, ignore the fact that we're doing a proof right now. I have an equation to solve right here. I want x all by itself. I need to get rid of the 4. X is being divided by 4. So if I want to get rid of that 4, I do the opposite operation, which would be multiplying by 4. If I multiplied this side by 4, it would get rid of the 4. If I multiply this side by 4, 4 times 12 is 48. Notice, that is what we were supposed to prove. We just solved this equation. We have proved that x is equal to 48 as soon as I can give a good reason for what I just did. Well, what I did was I multiplied both sides of the equation by 4. Anytime you multiply both sides of an equation by the same number, you're using the multiplication property. Multiplication property. All right, let's look at example 3. All right, if x times 8 minus 3 equals 4, then we want to prove that 8x minus 3x equals 4. All right, when we write a proof, we always start with the given. So I'm going to write the given in here. The reason I know the given information is always because it's given. Okay. Now, I want to prove this statement right here. Now, you don't always have the benefit of having the number of boxes here, but you're getting that benefit with this material here. What we're trying to prove is always the last step, right? How can I go from here to here? If I was just trying to solve this equation, I might not do it this way, but one thing you can do, because x minus 3 is being multiplied by x, you can distribute that multiplication. X times 8 is 8x. X times negative 3 is negative 3x. And that's how you get from here to here, by distributing x. So that is using the distributive property. All right. On example 4, if AB, the distance from A to B, then the distance from A to B is equal to the distance from A to B. So basically, this one's a little weird, but this basically just exists. It is. And so that was what was given to us. And then how do I know that AB is equal to AB? Remember, that's the exact same thing on both sides of the equation, right? Not just that they're equal in measures, but they are the exact same thing on both sides. Remember, that is the reflexive property. Just like looking in a mirror, looking at your reflection, it should be exactly like you. Both sides of that equation are exactly the same thing. Okay? Alright, let's look at example 5. Given that 3x minus 8 is equal to 19, prove that x is equal to 9. Alright, we start with the given. And notice your prove is x is equal to a number, so they have solved the equation. So let's forget for just a moment that we're doing a proof, and let's just think, how would I solve this equation? Well, I want that x all by itself. I got to get rid of two things, the 3 and the 8. We always get rid of the constant first, the number that's all by itself there. So if I was going to do that, I'd do the opposite operation. Opposite of subtracting 8 would be to add 8. So I would add 8 to this side, and that would leave me with just 3x. If I do it to one side, I have to do it to the other side, so I would add 8 to the other side. 19 plus 8 would be 27. Now what I just did was I added 8 to both sides. Anytime you add the same number to both sides of an equation, you are using the addition property. Now my equation is still not solved. I need to get rid of this 3 so that x will be all by itself. X is being multiplied by 3, so I do the opposite operation and we divide by 3. Now if I divide by 3 here, I get 1x, or just x. If I divide by 3 over here, 27 divided by 3 is 9. And notice that is what I was trying to prove. Now I divided both sides of the equation by the same number. I divided them both by 3 to get to this point. So I used the division property. Alright, example 6. We were given 3 times 2x plus 2 equals 30. That's what we were given. So again, let's solve this equation. What's the first thing I would do? I would distribute. 3 times 2x is 6x. 3 times 2 is 6. So I use the distributive property. Okay, I want x all by itself. I got to get rid of the constant first. It's being added, so I do the opposite and subtract. So I would subtract 6 to get rid of that. So all I would have left over here now is 6x. If I subtract 6 on this side, I got to do the same thing to the other side. If I subtract 6 here, 30 minus 6 is 24. And I subtracted the same number from both sides of the equation, so I used the subtraction property. And then I still need x to be by itself. I need to get rid of this 6 right here. X is being multiplied by 6, so we divide by 6. If I divide on the other side, 24 divided by 6 would be 4, and that does match what I'm trying to prove, so I feel confident I solved it correctly. And I got this last step by dividing both sides by 6. If you divide both sides of the equation by the same number, you are using the division property. Alright guys, last one. Alright, it is given that a times b plus 2 equals 45. That is given to us. Now that's not the only thing that was given to us. If I look at this equation right now, there's two variables in there. I can only solve for one variable at a time, and I'm supposed to prove what b is equal to. Notice, if I'm working on this equation, I only want one variable at the end. I only want b. Notice there's another given though. It tells us a is equal to 3. So a is equal to 3. That was given to me. Now what can I do with that? Remember in that equation I only want b. I don't want a in there. Well, I can substitute 3 in place of a because a is equal to 3, right? So in this equation I'm going to replace the a with 3. And what that does now is in that equation b is the only variable left. And I did that by substituting, so I used the substitution property. Now I need to continue solving the equation. Next step is to distribute the 3. So I got 3 times b, and 3 times 2 is 6. So I distributed, so I used the distributive property. Still want to get b by itself, need to get rid of the constant, so I'm going to subtract 6 because it was being added. So I subtract 6, that leaves me with 3b over here. If I subtract 6 on the other side, 39. So I subtracted the same number from both sides of the equation. So I'm using the subtraction property. And then I need to get rid of this 3. b is being multiplied by 3, so I divide by 3. If I divide by 3 on the other side, get b is equal to 13, which is what I'm trying to prove, and I did that by dividing both sides by 3. So I used the division property, divided both sides of the equation by the same number.